Welcome students. I am Srikanth, your chemistry mentor. Today we are going to discuss the topic biomolecules. Okay students, be ready with your pen and notebook. Otherwise take a screenshot. Okay, let us begin the lecture biomolecules. The living organisms require biomolecules for several biological processes like energy storage and regulation of their metabolic cycles. There are four major biomolecules, or we can call it as macromolecules, that are mainly involved in these biological processes. They are carbohydrates, nucleic acids, proteins, and lipids. These are the four major biomolecules are involved in the biological processes. Today we are going to discuss about carbohydrates, the definition of carbohydrates and the classification and functions in different organisms. So let us begin with carbohydrates. The carbohydrates represented with the empirical formula CxH2OY, where X and Y may be equal or may not be equal. Okay, let us take sucrose. C12H22O11, which can be written as C12H2O11. So let us take glucose. There is C6H12O6. This can be written as C6H2O6. But some compounds do not follow this precise stoichiometric definition. For example, acetic acid CH3COOH, which fits in this formula, like C2H2O2, but this is not a carbohydrate. For example, rhamnose C6H12O5, it doesn't fit in this formula, but this is a carbohydrate. Hence we need a new definition. So we can define carbohydrates as optically active polyhydroxy aldehydes or polyhydroxy ketones. We can define carbohydrates as optically active polyhydroxy aldehydes or polyhydroxy ketones. Here we know that poly means many, hydroxy means several OH groups, and either it has to contain an aldehyde group or a ketone group. So the carbohydrates is optically active and it contains many OH groups, and either it contains a aldehyde group or ketone group. So we have to remember the definition. Optically active polyhydroxyaldehydes or ketones are known as carbohydrates. So now we can go for the classification. So carbohydrates are majorly classified on the basis of degree of polymerization or on the basis of their behavior on hydrolysis. So classification of carbohydrates. The first one is on the basis of degree of polymerization. Or we can write it as on the basis of hydrolysis. Those are monosaccharides, oligosaccharides, and polysaccharides. So on the basis of hydrolysis or degree of polymerization, we can classify the carbohydrates into three major groups: monosaccharides, oligosaccharides, and polysaccharides. First, we will discuss about monosaccharides. Monosaccharides are the simplest carbohydrates and cannot be hydrolyzed into other smaller carbohydrates. So these are simplest ones, cannot be hydrolyzed further into smaller carbohydrates. Here we know that mono means one. So which shows the presence of only one sugar unit. These are the building blocks of disaccharides and polysaccharides. Most of the monosaccharides names ends with the suffix "ose", like glucose, fructose, galactose, ribose. These are the examples. Glucose, fructose, galactose, ribose, etc. Glucose is also known as dextrose. Fructose is also known as lactose. Okay, now we will write the simplest monosaccharide containing aldehyde group is glyceraldehyde. So this one is the simplest monosaccharide with 3 carbons containing CHO group, aldehyde group. Now CH2OH, C double bond O, CH2OH. This is another simplest monosaccharide, is known as dihydroxyacetone, dihydroxyacetone, which is also containing 3 carbons and 1 ketone group. Generally, the monosaccharides are colorless, water soluble, crystalline solids. So the physical properties are, these are colorless, water soluble and crystalline solids. Now we move for the oligosaccharides. Oligosaccharides, which yield 2 to 10 molecules of same or different monosaccharides on hydrolysis. So on hydrolysis, which yields 2 to 10 molecules of monosaccharides of same or different monosaccharides. All the monosaccharides are joined with a glycosidic linkage. So this is a monosaccharide and this is another monosaccharide which can be joined with a glycosidic linkage. This is called as glycosidic linkage. On the basis of the number of monosaccharides attached, the oligosaccharides are classified as disaccharides, trisaccharides, tetrasaccharides, pentasaccharides and etc. If 2 monosaccharides attached with the glycosidic linkage is known as disaccharide. If 3 units are linked, then it is called trisaccharide. So the example of disaccharides are sucrose, lactose, maltose, etc. The examples for trisaccharides are raffinose, melazitose, etc. And the tetrasaccharides are stachyose, maltotetrose, etc. So oligosaccharides on hydrolysis, the oligosaccharides on hydrolysis, they give 2 to 10 units of monosaccharides. So on the basis of monosaccharide attached with the glycosidic linkages, we can classify further into disaccharides, trisaccharides and tetrasaccharides. Now we go for polysaccharides. Polysaccharides are a chain of more than 10 carbohydrates, more than 10 monosaccharides joined together through glycosidic bond formation. Simple. Monosaccharides are the simplest saccharides which cannot be hydrolyzed further. Oligosaccharides are on hydrolysis, they give 2 to 10 units of monosaccharides. Polysaccharides on hydrolysis, they give about 10 units of monosaccharides. The examples are starch, cellulose, glycogen. gums, etc. So we can go for the other classification. The carbohydrates are again classified on the basis of the reducing nature. So they are classified as reducing sugars, non-reducing sugars. So we can classify on the basis of their reducing nature. They are classified into two types: reducing sugars and non-reducing sugars. Reducing sugars are a sugar serves as reducing agent due to its free aldehyde or ketone group in its molecular structure. So the must thing is it contains a free aldehyde or ketone group in its structure. And also it reduces Fehling solution and Tollens solution. Fehling solution, it is a deep blue color alkaline solution, contains copper sulfate. For aldehydes, the color of the solution turns into dark red precipitation of Cu2O and copper 1 sulfate. It doesn't give any change in color for ketones. For aldehydes, the deep blue color alkaline solution turns into dark red color. Okay. Next, for Tollens reagent, Tollens test is very useful method to distinguish between aldehydes and ketones with ammonical silver nitrate. With ammonical silver nitrate. For aldehydes, the colorless solution turns into gray precipitation. It is called silver mirror. But for ketones, there is no change in color observed. Only for aldehydes. For ketones, the color change will not be observed. All the monosaccharides and oligosaccharides except sucrose are reducing sugars. All the monosaccharides. And oligosaccharides also are reducing sugars except sucrose. All the monosaccharides and except sucrose and all the oligosaccharides are reducing sugars. So for non-reducing sugars, these do not reduce Tollens reagent and these do not reduce Fehling's reagent, all these things. And they doesn't contain free groups. They doesn't contain free aldehyde and ketone groups are called non-reducing sugars. The non-reducing sugars cannot reduce failing solutions and tolling solutions. So all the polysaccharides are non-reducing sugars, and also sucrose. Among oligosaccharides, sucrose is non-reducing sugar, and all the polysaccharides are also non-reducing sugars. Monosaccharides further classified on the basis of carbon atoms and functional groups present in them. So if monosaccharide contains aldehyde group is called aldose. If it contains aldehyde group are called aldose. If it contains a ketone group is called ketose. On the basis of carbon atoms in the monosaccharides, if it contains 3 carbon atoms and has a aldehyde group, then it is called aldotriose. And if it contains ketone group is called ketotriose. If there are 4 carbon atoms consists in the carbohydrate and contains a aldehyde group is called aldotetrose, and for this ketotetrose. Like that, aldopentose, ketopentose, all these things. So what we have learned today? So the biomolecules, the carbohydrates, nucleic acids, proteins and lipids are the 4 major biomolecules we are going to be discussed. So first we are going to discuss about carbohydrates. The carbohydrates, the general formula is CxH2OY. So this is not applicable to every carbohydrate. It is called as hydrates of carbon. So for sucrose, glucose, all these things, the formula fits. But for acetic acids, the acetic acid fits in the formula, but it is not a carbohydrate. For ramenose, it doesn't fit in this formula, but it is a carbohydrate. So we define the carbohydrates as the optically active polyhydroxyaldehydes or polyhydroxyketones. And we classify the carbohydrates on the basis of polymerization as monosaccharides, oligosaccharides and polysaccharides. Monosaccharides are the simplest carbohydrates and cannot be hydrolyzed further into smaller carbohydrates. Examples: glucose, fructose, galactose, ribose, all these things. And oligosaccharides, on hydrolysis, it gives 2 to 10 units of monosaccharides, and they are attached with a glycosidic linkage. If there are 2 monosaccharides are attached, are called disaccharides. If 3 units are attached with a glycosidic linkage are called trisaccharides. And if 4 monosaccharides are linked with glycosidic linkage are called tetrasaccharides. Now go for polysaccharides. On hydrolysis, the polysaccharides produce more than 10 units of monosaccharides. The examples are starch, cellulose, glycogen, gums, etc. So we further classify the carbohydrates on the basis of their reducing nature. They are classified into 2 types: reducing sugars, non-reducing sugars. Reducing sugars contains free aldehyde and ketone group, and for non-reducing sugars, the functional groups are not free, they are bonded, closely bonded. The reducing sugars reduce the failing solution and tolerance reagent. So ketones doesn't give the positive results, but aldehydes give. So the non-reducing sugars doesn't give result for failing solution and tolerance reagent. All the monosaccharides and all the oligosaccharides except sucrose are reducing sugars. All the polysaccharides are non-reducing sugars, and sucrose among oligosaccharides is also a non-reducing sugar. So this is for today, and tomorrow we are going to discuss about the structure of monosaccharides, that is glucose, maltose, lactose, all these things. Thank you guys.